So now, in the previous lecture, we have studied velocity is equal to V is equal to C root over RS, where I told you that the C is your Chezy's coefficient. Now, I told you that I asked you basically that if this value of C is not given to you, then how come you can calculate or compute the values? So, various researchers have given different formulas for calculating the value of Chezy's coefficient. So, first one is your Ganguet-Cutter's formula or Cutter's equation. This is very much famous in the name of Cutter's equation sort of. Fine. So, what is this value of C can be written as 23 plus 0.00155s plus 1 by n. This is equal to 1 plus 23 plus 0.00155s in bracket, and this is n root r. So, this is the whole formula which you get by solving Ganguet-Cutter's formula, that is Ganguet-Cutter's equation also you can say, with the help of which you can compute the value of your Chezy's coefficient. Fine. Now, this is one formula. Second one, this S is your slope, N is your constant, this is the same. Now, second one is your Bason's formula. Second one is your Bason's formula. Bason's formula, which is equal to C is equal to 157.6 1.81 plus m root r. This is one formula. Till now there haven't been any questions like you have to compute the value of Chezy's coefficient with the help of Cutter's equation or with the help of Basie's formula or Basie's equation. Fine, but still you never know, I have told you this 157.6 1.81 plus m root r. What is this m? M is a constant and it depends upon the type of its value, depends upon the type of channel surface, for smooth, for rough, and various permutation and combinations. So, value depends upon the type of channel surface. Fine. So, from here you can compute the values of your Chezy's coefficient. Now, there have been another way through which you can calculate the average velocity, and that formula is known as your Manning's equation. That is known as your Manning's formula or Manning's equation. What is this Manning's formula? The expression for Manning's formula for calculating your average velocity is given by V is equal to 1 by n r to the power 2 by 3 s to the power 1 by 2. Here r is your hydraulic radius, that is ratio of wetted area to that of your wetted perimeter. S is your slope and n is your Manning's roughness constant or coefficient. So, you can write Manning's roughness coefficient. Fine. In question, generally they give you the value of n, r and s if you want to calculate the value of velocity with respect to your Manning's formula. Now, as here what you did, you calculated the value of C. If it is not given, you use these two equations. Similarly, here if you haven't been given the value of Manning's roughness coefficient, there are ways with the help of which you can calculate or compute the value. So now what is that? First one is your Strickler's equation. Strickler's equation. This question, based on this question, had already been asked in your GATE examination. Fine. The n is equal to d50 to the power 1 by 6 divided by 24, or you can write k to the power 1 by 6 divided by 24. Now what is this k? K is basically your roughness height, first thing. Fine. And the second one is, what is your D50? This you have already studied, D50, D10, this all you would have studied. So what is that? D30, basically D30, D60, D10 you would have studied. What is this D50? Based on that, can you relate it? What is the meaning of this D50? The D50 is 50% of the particles are finer in size. Fine. The most important thing is, since it is an empirical formula, so what happens in empirical formula? These end results are derived with lot of experiments, lot of researches. So whatever units has been specified, you have to convert your given problem units in this formula unit. So here D50 and K both are in meters. Fine. So whenever you have to calculate the Manning's coefficient, Manning's roughness coefficient, you have to substitute the value of D50 or K in meters for getting the Manning's coefficient. Now, this is first formula. What happens if you have excess of coarse grained particles, that is for higher percentage of coarse grained particles, of our beds having higher percentage of coarse grained particles. Here what you use? Here you use Mayer's formula. Mayer's formula, which will give you Manning's coefficient constant as D90 to the power 1 by 6 divided by 26. This is the formula for your Mayer's equation, fine, from where you can get your Manning's roughness coefficient. So here you have seen, there also you got two formulas. Which one it was? It was your Gangwit-Cutter's formula, fine, and other one was your Bason's formula. Similarly, here you got Strickler's equations or Strickler's formula and your Mayer's formula. What is this? Just one thing, there is a difference. Here also D90 will be in meters. Fine. Here it was 24. Here this is 26. Fine. And what is this D90? 90% of the particles are finer in size. So you can write D90 is, or you can say 90% of the material will pass. So 90% of the particles are finer in size. Fine. So from here you got this result. So just mark it in blocks. I haven't done it, so that you can see at the end time. This one is important. Fine. Now just one thing more in this. What is the factors, or what are the factors on which your Manning's roughness coefficient depends? Come on, tell me. You can tell this. Imagine there is a channel surface, and could you tell me, depending upon these formula, that what are the factors on which your end depends? Till the time I write. following factors on which Manning's roughness coefficient depends. So I'll write following factors on which n depends. Come on, you got something? Can I write alignment of canal, the way in which the canal is aligned? Fine. So I can write, yes, it depends upon alignment of channel. You can see V is equal to, here in the formula, 1 by n r to the power 2 by 3 s to the power 1 by 2. And what is this r? R is your hydraulic radius and which is your area to the perimeter. So does it depends upon the cross section? Yes, n depends upon the cross section. So I can write it here, cross section irregularity. Third, it depends upon the type of channel surface, whether it is rough, whether it is smooth. So I can write it as it depends upon surface roughness. And the last one is your vegetation. So these are the 4 factors, that is how the canal is aligned, what is the cross section irregularity, the surface roughness and your vegetation, on which your value of Manning roughness coefficient, or you can say constant, depends. Fine. So I have told you 2 formulas for calculating the velocity. This, if you are a very new student and you don't have any knowledge regarding open channel flow, these 2 formulas you should practice n number of questions, so that this formula you are very much prone of using these formulas, because these formulas are very important in your open channel flow. And this, since the question has already been asked in GATE examination regarding this formula, so you have to solve questions so that this formula will come in your practice. Fine. After this, there is a small topic, just it will take 2 to 3 minutes, is your conveyance. What is this conveyance? Have you come across this word? Come on, tell me, have you come across this word conveyance? Okay, before moving to conveyance, let us start simply. I'll tell you one thing first. Conveyance is denoted by K. Fine? Don't confuse this K with your Strickler's equations K. Fine, that is your roughness height. So now, can I write first of all, discharge is equal to area into velocity? Fine. Now, if I want to write velocity with the help of Manning's formula, how can I do it as 1 by n r to the power 2 by 3 s to the power 1 by 2. Have I written it correct? Come on, just participate when I am telling it. Fine, Q is equal to area into velocity. In place of velocity, I have written Manning's formula. Now, what I will do is, this slope, what I will do it, I will put it here. Can I write it like this? Which was in multiplication, I transposed it and it came into division. What I got it here, 1 by n a r to the power 2 by 3. So this Q by root s is equal to K is your conveyance. That is, if in any question you have been given the value of conveyance, that means, and they have asked you to calculate what? Discharge. That means they have given you this value. Fine. So what I can write? Conveyance is defined as the ratio of discharge, or you can say conveyance is defined as discharge carrying capacity of the channel per square root of your longitudinal slope. So I can write it is the discharge carrying capacity . discharge carrying capacity of channel per square root of longitudinal slope. Fine, because questions can be asked, they can give you conveyance and they can ask you discharge or something like that, any of the following parameters. So you should be able to know what is this conveyance for and how you use it based on numericals. Fine. So here I told you what is conveyance, Strickler's, Manning's, everything. Now we will solve some numericals so that you will be able to solve questions and you will get confidence how these formulas can be used. So now we will be proceeding towards the numerical part. So now open your booklet, we will be solving questions. So we will see question number 1, MCQ and NAT question. Question number 1, MCQ and NAT question. So let us see the question. You also read it with me. Consider a wide rigid boundary canal with bed slope of 0.004, Manning's n is 0.18 and depth of flow is 0.08 meter. The average boundary shear stress will be. So you have been given a wide rigid rectangular channel section. So first of all, let us write what all is given to you. They have given the bed slope S is equal to 0.004. Fine. Manning's n is given to us as 0.18. Depth of flow is given 0.08 meter and we have been asked to calculate the boundary shear stress. Fine, this is the question. Now let me draw first rectangular channel section. So this is your rectangular channel section of width B, fine, and your depth of flow. Now what is happening? You know, first of all, just see how can we calculate the value of tau naught. You know the formula that boundary shear stress can be calculated by gamma RS. Fine. Now, gamma value, if you can see the option, it is in Newton per meter square, and you know gamma is equal to 9.81 kilonewton per meter cube. But if I want to get the value in Newton per meter cube, I will write it as 9810 Newton per meter cube. Fine. But now you know that hydraulic radius is what? Come on, tell me now. I won't tell you again and again. You should be able to participate. What is this hydraulic radius? It is the ratio of your wetted area to the wetted perimeter. But can you see, except the depth of flow, you have been given width, or have you given any velocity so that you can calculate the width? No, you haven't been given, right? Never. Now just see. In the question it is written, consider a wide rigid boundary rectangular channel section. So if it is a wide rigid boundary channel section, so can you say that width is very greater as compared to your depth? I told you this, fine, and you know that R is equal to A by P. So if it wasn't have been a wide rectangular channel section, what it was, A will be written as B into Y and perimeter will be this portion, this depth and this depth. So you can write it as B plus 2Y. Now if it is a very wide rectangular channel section or wide rectangular channel section, what you will get? B plus 2Y will be equal to B. So from here R is equal to Y. This I told you earlier also, but I am telling you in case you haven't recalled or revised the initial one, from here whenever you get a wide rigid boundary rectangular channel section, hydraulic radius will be equal to your depth of flow. So here what can I write? Tau naught is equal to gamma into y into s. Just one thing more, what do you people do if I say that r is equal to y, in every formula you put it, you don't look at the channel section also, that whether it is trapezoidal, whether it is circular or whether it is triangular. So I am telling you this is exclusively for rectangular channel section. So now gamma is equal to 9810 Newton per meter cube. Y is your depth of flow is given 0.08 meter and slope is given to you as 0.004. Fine. So from here you can solve 9810 divided by 0.08 into 0.004. So you got the value as 3.1392 Newton per meter square. You can write it as 3.14 also. So this is your tau naught. So if I look at the option here, they have also rounded off in 2 decimal places, that is 3.14 Newton per meter square is your tau naught. Option B. So option B is your right answer. So you saw this is a very simple problem, provided you know that tau naught is equal to gamma rs. If this formula is known to you and you know the condition that for wide rectangular channel section, your hydraulic radius is equal to your depth of flow. See, it happens some students can say that you are telling the same thing again and again, but I am telling the same thing again and again, then also you are making mistakes. Fine, that is why my voice, my words goes in your brain and you don't commit such silly mistakes. I am telling you. Fine. So for this question, option B is your right answer. Thank you. So now we will be seeing common data question 2 and 3 for your chapter 2 uniform flow. So question number 2 and question number 3, MCQ and NAT question for your chapter 2. So now let us look at the question. A rectangular open channel needs to be designed to carry a flow of 2 meter cube per second under uniform flow conditions. The Manning's roughness coefficient is 0.018. The channel should be such that the flow depth is equal to half the width and you have been given the Froude number equal to 0.5. So first of all, let us write down all the data, that is they have given you discharge 2 meter cube per second, Manning's N is 0.018, then the channel flow depth is equal to half the width and your Froude number is given to you as 0.5. This is the data which is given. So let me draw a rectangular channel section first, a rectangular open channel. This is your width and this is your depth of flow. Condition has already been given that your depth of flow is half that of your width. Now let us look what is the first question they are asking. The bed slope of the channel to be provided is. What is the slope which is to be provided? This is the first part of your question. So now, since first of all you see you have been given Manning's coefficient, so you use Manning's formula for calculating the velocity. Now, how can we approach? Do you know that Q is equal to area into velocity? This you know, right? Now, Q is equal to, in place of velocity you can write 1 by n r to the power 2 by 3 s to the power 1 by 2. Now, in this question, except Q and N, not even a single value, that is neither hydraulic radius, neither area is given to you directly. So what we have to do, excuse me, first you have to calculate the value of A and R, then you can calculate the slope. So how could you do that? You know that area of rectangular channel section is B into pi. But from here you have seen B is equal to, can I write it as B is equal to 2y? Yes, I can. So area will be 2y square. Similarly, if I am asking the perimeter to be calculated, it will be B plus 2y, this one and this flow, length of the boundary in contact with water. So B is what? B is here, you can see it is 2y. So 2y plus 2y will give you perimeter as 4y. So you got the area and you got the wetted perimeter. You can calculate the hydraulic radius, which is your wetted area by wetted perimeter. So you can get it from here, 2y square by 4y, which is equal to your y by 2. So you got the value of R, you got the value of A. But now there is one more hindrance. You can see the value of A and R, what you got is in terms of y. Fine? Already there is an unknown slope and you haven't been given in the question the value of y. So could you tell me, is there anything, this is the given portion, with the help of which you can calculate the value of y? Come on, just tell me. Use your brain. I am giving you from Froude number, you can calculate your depth of flow, that is y. Come on. Now, I will tell you. You know that Froude number Fr is equal to V root over G D. This is the generalization form of Froude number. But when it is the case of rectangular channel section, your hydraulic depth, which is the ratio of your wetted area to that of the top width, that is By, and your top width is V, it will be equal to y. Here I derived it again. Now anywhere rectangular channel section comes, I will write it d is equal to y. Fine. So Fr is equal to V root over Gy, and I will do it for rectangular channel section, V root over Gy. This is exclusively only for rectangular channel section. So now, have I given the value of V directly? No, I haven't been given. But you know that Q is equal to area into velocity. Area you can write it what? Area you have been given 2y square. So area you can write it as 2y square. What is Q? Q is 2 meter cube per second. So from here, what you got the velocity? You got it as 1 by y square. This is understood, right? This appears more like z. So this is y square. Q is equal to area into velocity. Area is width into your depth of flow. So width is 2y into your depth of flow is y. You got 2y square into v. 2 and 2 get cancelled out. V is equal to 1 by y square. Now, I will substitute the value 1 by y square into root Gy. You could directly substitute the value, but like you use what? You use your virtual calci while solving. So in place of this under root and all, it's better you square on both the sides. So squaring on both the sides will lead to you G. Here you will get y to the power 4 and here you will get y. So you will get y to the power 5. So we will substitute the values. Froude number you got 0.5. So 0.5 square, here it is 1. G, that is acceleration due to gravity, is given to you as 9.81 into y to the power 5. So from here you can calculate the depth of flow. 1 divided by 9.81 into 0.5 square. You got the value as 0.4077, but this value is y to the power 5. So for getting the value of y, I will get it as 0.8357 meter. Just take 3 decimal places or 4 decimal places for more precision. Fine. So from here you got depth of flow, but I was not interested in getting the depth of flow, means I haven't been asked the depth of flow, I have been asked the slope. But for getting the slope I needed to get the depth of flow. So this is, first let me write it, this is, area is given to you as 2y square. 2y square 1 by n, this is r is y by 2, 2 by 3 and slope. Now substitute the values, you got every values now. Q is given to you as 2 meter cube per second, y square, so y is given to you as 0.8357 square, Manning's constant n is 0.018. What is your y? Again it is 0.8357 by 2 to the power 2 by 3, and this is your slope. Now you have to calculate the values and get the slope. First this 2 will get cancelled out first of all. So now let us solve it. 0.8357 square into 1 divided by 0.018 into 0.8357 divided by 2 to the power 2 by 3. So from here you got the value as 21.6857 into s to the power 1 by 2. So 1 divided by will give you s to the power half, comes out to be 0.04611. So square root on both the, squaring on both the sides will give me the value of slope. So square root on both the sides will give me 2.126 into 10 raised to power minus 3. So let me look how, in which manner it has asked me. Yeah, this has asked me in the same manner. I was thinking that 1 upon it is asking or what. So I can write 0.002126 is your slope. Fine. So according to the options, if I can see, it is option B. Option B, that is 0.0021. So here also it is 0.002126. So option B is the right answer. I did it very slowly, step by step, because the concepts would be new to you. So just to tell you how to approach the problem, otherwise you don't have to do all this, you can calculate it in a single line. Fine. Now moving to the second part of this question, keeping the width, flow depth and roughness the same. So now what it is telling, the width, flow depth and roughness is same. If the bed slope of the above channel is doubled, means initially the bed slope was S. So now if the bed slope is S dash, it will be 2 times the bed slope. Fine. The average boundary shear stress under uniform flow conditions. So what happened is, only what you have to do, you have to double the initial slope and you have to calculate the boundary shear stress. So tau naught is equal to, you know that it is gamma RS, and it has asked in Newton per meter square. So you will put it here 9810 Newton per meter cube. R is what? R, you have seen it here, I have done it already. It's y by 2. And what is y? That also you have calculated it, 0.8357. So 0.8357 divided by 2. And slope you got it as 0.0021. Fine. So this calculator is that side. So now we will calculate this 9810 into 0.8357 divided by 2 into 0.0021. So from here you got the value as, just a thing, I did a mistake. This is S dash. So it won't be this slope, it will be multiplied by 2. Getting it? Because it has already mentioned in the question that the slope should be twice the initial slope which you got, because the bed slope is doubled. So I will solve this. 9810, anyways this 2 and this 2 will get cancelled out, into 0.8357 into 0.0021. You will get the value as 17.216 Newton per meter square. This is the value of your shear stress. So, if you see, your option D will be the right answer.